Huh, interesting. Yeah, it's recording from the first machine that I logged on from. So progress on this end. Let me try to open up Slack here and show you. So I had a little bit of progress and then need some advice. Fundamentally, the advice I need is suggestions on how to debug getting different results in the simulator versus in the real world, because that's the situation that I'm in. I'm getting results in the simulator that are, fine, and results in move-based flex in the real world that are not fine. So if I share my screen and show you what I'm talking about. Share screen. So my effectively what I do is drive my tractor into my yard, get all of the sensors and all of the software running, and then execute a 2D nav goal and basically say, go 5 meters in this direction, which is pointing east. And that is the command that I give it. In this particular case, it was down here, which it will do in the simulator without any drama. And in this case, it drove around and around, and I stopped it because you can't see it, but their next door neighbor has a fence here, and I thought it was going to back into the fence. And so in the first attempt, I stopped it before it backed into the fence. In the second attempt, I moved it out into the center of the yard and tried it again. In the second attempt, it behaved in a similar manner in that it attempted to drive but never reached the goal. And there's a bag file out here that you could run, and it shows how it never really gets to its goal, and tries a series of forward and reverse, but just never gets there. So my problem statement at the moment is, at a very high level, behavior in the simulator is not the same behavior in the real world, and how do I debug that? That's sort of where I'm at.
On that first image you did it actually drive to the right and then it stopped and started backing up? Is that what it did? Mm-hmm. You do have a straight line on there. That's what it did. It's probably, if that's what it did, it's probably because your goal is not set to the point. It's probably set, even gets close and just says, I've reached the goal, and it will stop. Now, if it's you haven't backed that off in the actual lawn tractor, when it gets there, if it's not pointed exactly the right angle or not exactly right on top of that spot, it's going to say, oh, here, let me try to maneuver around to get back on that spot. So it might start driving around trying to, if you miss by just a little bit, instead of stopping, it's going to say, oh, let me go drive around for a while, see if I can hit that spot exactly. So that might be part of your problem. So if you go into your parameters for move base flex or move base or whatever it's called, there's something going to be called goal tolerance, and there's one that's an angle. So you either have to hit it at exactly an angle you told it, or it's gonna do some driving around to correct for that. Or you can also you can even say, if you're within a meter, stop. So you can set it way out. You can say a meter away and stop, and set the angle to you can pick. It's either 0 or whatever the highest number is, and it won't care at all. Once it gets to that spot, it'll just come to a stop, and everybody will be happy. So that's something to look at. And I don't know what the difference is
Chef?
between that and the simulator.
Chef?
Yes.
Hi, good morning. What's that the file that you say, how it's called, goal?
I think it's called goal tolerance. And there's probably a goal tolerance angle and a goal tolerance like position or something. I'd have to go
Okay.
look it up to see what that is, but so basically you can change those numbers to the point where it just gets close, it'll come to a complete stop and everybody will be happy. And I was noticing on the watching the simulator stuff run, it doesn't seem, if you tell it to go to a position, it just goes there and stops. It's not trying to get the angle correct when it gets there, I don't believe. So I think on the simulator, those numbers have probably been backed off to the point. It just says, when you get close to the point you're supposed to be, just come to a stop and not worry about if you're lined up correctly or not. And if you had a differential drive robot,
No.
So whereabouts am I looking for?
I would start on the Ross wiki and look up move base flex and then search for, maybe just search for tolerance and see what shows up on that page. I mean, I'll try to pull it up and see. I see they don't show up on this page. It probably says go look here for documentation, so it's probably somewhere else. It probably says go look here for documentation, so it's probably somewhere else. That was kind of a funny echo. It went away now. So. It went away now. Al, do you have audio turned on both computers? Al, do you have audio turned on both computers?
Huh. I think that you have to access again with the link in the other computer. I will go and get my headphones.
I just Googled move base flex tolerance.
if you go look at your parameter file you're using, they would already be in there, but that's not guaranteed. It might be just using whatever the default is. But you might just be able to pull up your parameter file. You know, when you start move base flex, you're going to point to a file that says, here's the parameters. It could be you could just search through that and find it.
In the wiki, there's a section called parameters. It's happened to be section 5 for common parameters. And underneath it, it says to do.
Yeah, I see that. Probably if you go to, at the top somewhere, it's going to say, this is, the source code is located here. It says source is on GitHub, Magazino, MoveBase Flex. Probably there they'll be listed. Otherwise, I'm not sure how you find the, without digging through the source, I'm not sure how you find the parameters. Oh, it says also see MoveBase Flex documentation and tutorials in the ROS wiki. And then it says this repository contains minimal configuration for Turtlebot 3. So let me check the first one here. No, it just took me back to the MoveBase Flex page that said to do. Now the one right below where it says getting started, it says configuration for Turtlebot 3. I'll see what's, there's a directory called param. Probably just go back to MoveBase, because they should be the same between MoveBase and MoveBase Flex. And MoveBase is probably defined, probably documented. And there they'll tell you what they're called. And typically on the ROS stuff, it'll have a page for, say, MoveBase, and then somewhere it'll say under tutorials, it'll have something from MoveBase. And on the MoveBase page on the ROS wiki, they kind of go through and explain things with, it says eventually it'll get within this tolerance of the goal and signal a failure or whatever. So they give you more description there about what it's doing. So let me continue on. No, there's only 2 instances of tolerance on this page. But it's going to be called something like goal tolerance, I think is what it's called.
Yeah, to be clear, I never received the goal achieved.
Yeah, it's because it's still looking around for it is what happened. You got to that point and it says, oh, if you have a differential drive robot, what it will do, it'll drive to that point and it will stop and it'll rotate in place until it rotates to the angle that it wants. Or if you didn't hit it exactly, it may decide to drive around. It'll do a little dance until it actually hits the point. But with an Ackerman drive vehicle, the only choice you have is to drive in big circles to get back to hit exactly that point that you're looking for. So that's why I think on the, because when you watch it on the simulator, I think it just drives to the point and stops, and it makes no attempt to hit it at the right angle.
No, I in my experience, sometimes it makes that corrections forward and backward to get to the angle, but it's minimum compared to a robot that is in real life because you don't have bumps in the simulator.
And Juan, I think you said.
I think that I have the same problem that you have. The last time that I used, while I was trying to use my robot, I was having similar problems to yours. And I think that another approximation that we talk about is to shut down the possibility of going backward, only going forward. So you relieve the pressure over the actuator that is pushing forward and backward. So the tractor will have to go always in rounds as Chef told. It's another approach, but I think that what he's saying, Chef, is the best thing to try.
And how do you turn off the reverse option?
You have to go to the TEP planner and work it there. I
found the stuff that I was looking for.
Yes. Gold tolerance plan. Okay.
Can anybody hear me right now?
What? I'm
I
seeing
your
your
audio.
button for my mute and image.
Yes, we are looking to a page that says 422 gold tolerance.
Okay, I just checked to see if my audio is working, and it is. So let me go back and again.
Okay.
Okay, so if you look in the chat, I posted the link to this file, and this is actually the planner that is inside of the thing that's doing the moving around. And I'm not sure. Flex, I don't know what you have loaded as the local planner there, but this is one of the two major local planners, and that's where the values are here. So it could be if you put these values in, will says so you got angle tolerance. So that says when you get there, the angle's not correct, and by default it's 0.05 radians, and that's pretty damn tight. So if you don't, somewhere it'll say, somewhere it says if you make that number either really big or really small, it'll just ignore it completely. So once it gets there, it just comes to a stop. And then the XY goal says once you get there, if you're off by say a centimeter to the left or the right, instead of trying to drive around and correct, it'll just come to a stop. So you can make that. It's set to 1/10 of a meter right now. And just as a quick experiment, set that to 1 meter. So if you get within 1 meter, that'll keep that happy. And then set the goal tolerance. The tolerance within that, probably set that to like 6.28, which is, you know, a full circle. Then anything when you get there, it'll keep both of those happy. So that might fix your problem. And then as Juan says, go into the actual TEB planner and say don't allow it to back up, and that might help out too.
But I think that yours is much better approach. In the long run, for the robot, maybe use the TEP planner it's okay too, but this is much better.
I think you definitely want to go change this goal tolerance, and I'm still thinking if you look at the simulator, it's probably modified there, but I don't know that for a fact. Since I don't actually run the simulator, I can't tell you what's in there or how it works. It's just when I've watched it running, that's kind of what it looked like it was doing. So anyway, that's that. I posted the link to that file to give you an idea. Another thing you can do is when you first start up your software, you know, at the very top, it lists a bunch of parameters that it's going to use, and see if it's got the goal tolerance stuff listed in that. Now, it could be that it only defines it if it's not set to a default. And I guess right there, that would tell you if you run your software on your lawn tractor and it lists all the parameters it's going to use, and it doesn't list goal tolerance. But if you run the simulator and it pops up, it does show goal tolerance. That's something other than default that will say that yes, that is modified in the simulator.
Yeah, I don't recall that it mentioning any of the specific parameters. I could probably pull up the bag file and look at the ROS out message to see exactly what it said. But
I
that's
don't
at least an
recall
area
if
to dig
those
into.
are. Yeah, I don't recall if those are specifically listed in the ROS bag file, but they might be. You know, when you first say start this launch file, and it just puts stuff up on the Linux screen, that's where it would say that. It says I'm starting, say, move base flex, and then under that it lists parameters that it's going to use. I think is how that works. So I don't know if that gets put into your bag file or not. It could be if you go look at your log files. So you've got what is it, dot? I think there's a dot ROS underneath your main directory, and then under that's where your log files are. That I think will have, you know, last time you run it at least. It's gonna have a whole bunch of log files in there. You have to go dig through them and see which one. Somewhere I think it's called current or latest or something, and that'll show you what it was the last time. Otherwise, it archives them all. So there's gonna be a whole bunch of them in there that go back they go back till you take up 1 gigabyte of space, and then it starts overwriting them, I think.
And this is referring to base local planner. Is that
And
this?
I'm guessing any of the local planners are going to have the same type of parameters on them, but I'm not sure. By default, I think if you just run standard move base, you either get that planner, the DW rollout planner or something, so you can select between one or the other. So now that people have loaded move base flex, I'm not sure what it's using as the local planner and that.
Well, it's definitely a place to dig into. So that's where I'm at. Is to try to get the real world to act like the simulated world and figure out how to debug it. You know, and I thought the simulated world would always act like the real world.
Okay.
See, I got a smile out of Jeff. Yeah, you know, it's hard to do that, Juan. You know, put a red dot by today's date. Got a smile out of Jeff.
Yes, but you are. That's. I think that you are pretty good working now. That in that line.
Oh yeah, I can go when I'm just from ear to ear.
Yes, but the it's you are much better than last month. I think that everybody got this problem because the last time that Vinny came to the meeting, he was talking about this, how to build a better bridge between the simulation and the tractors. And that's where we talk about the tech planner and those things. I think that one of the problems is this one, the granularity that is talking about in the goal tolerance parameters. I was trying to load up the simulator to search for the goal tolerance parameters.
Well, it's raining like crazy in Pennsylvania.
Here
At
in
the
Pittsburgh?
moment. Hopefully,
Yes.
we'll be able to have a little bit of time to test this.
Chef, you got something to share?
One more comment on your testing. If you set those goal parameters down to the point where it just gets close and comes to a stop, I think it'll get to the point where if you say specify a goal location, it should drive forward and come to a stop. And if you keep picking goal locations that are more or less out in front of you, I think it will then try to drive to that location without trying to back up. So that would be something interesting to try. If you succeed in going from where you are to some point straight out in front of you and it comes to a stop, if you can successfully do that, then I just pick some more points, you know, pick another point out in front of you somewhere and verify it'll move to that, you know, maybe off to the side so it has to turn a little bit or something. And if you get the point, you can just start clicking around and drive it around, then that would be a major accomplishment. But if you pick something that's not out in front, then the TEB planner is probably going to try to back up and go to it, which may or may not be a problem, you know, that, but that's something you're going to have to test to see if that is a problem or not.
Yeah, to be clear, I have pointed the tractor east and giving it a goal 5 meters east in front of it, so that it just has to go straight forward 5 meters. I mean, that's the first test that I've tried to give it. And that's when I went,
That's why I think changing that goal tolerance will solve that problem. I think it'll drive forward and stop. If you set the XY really big, like say 1 meter, it may go 4 meters forward and say, oh, I'm close enough, and it'll come to a stop. But that, I think, will prevent it from driving around wildly then if you do that.
yeah, so we'll save the more complicated goals for if we can just do 5 meters forward straight.
And in fact, if you can get it to go 5 meters straight and stop, then execute that again, the exact same thing, go 5 meters straight again and stop, and then get a little more creative and pick a point that's not exactly on the line and see if it will actually curve and go to that point and come to a stop. So it's just a matter of progressing. You know, once you get to the point where it'll move and stop, then you're in good shape, and then you can move on and decide, you know, what else will it do or not do at that point.
Roger that. Okay, that's enough of me blathering on. Jeff, Juan, Bob, anything?
Well, the only thing I have is that, you know, I showed the pictures of my steering motor moving, and it's awfully noisy due to that. The PWM command is built in the Arduino, so I either have to find a different library that gives me a faster PWM, or I have to go and start playing with the timers myself to make it run better. I did one thing that I thought was kind of clever. I've got some code in there that just says watch the pot on the motor, and if it gets beyond a maximum range or minimum range, it just kills the motor power. And I mainly did that so I don't smash the pot while I'm experimenting here, but it actually may be handy in the real world, because say if your pot gets loose and turns somewhat, then you can just put a limit and say, well, if we somehow hit the limit that we've set, you know, mechanically we shouldn't ever hit that, but if it gets loose, that might happen. So that might, again, if something's loose, it might prevent damage by doing that. And the other thing I thought, well, say if I put this right on the lawn tractor like this, I could set the limits beyond the 2 end stops, so that, you know, it's never going to shut the motor down. It's always going to go bang from one end stop to the other. And if you don't want it actually going all the way end stop, I can just reduce those numbers down. So I set a number just inside of each end stop. And when it gets to the end, the motor just automatically stops before it hits the end stop. That's going to limit how sharp you can turn. But depending on what you're doing, that might be something you'd want to do. So anyway, that seemed to be working. And
Yes. I can.
And the motor
show you.
controller you're using again, I'm catching up on your posts.
it's basically the same thing that everybody else has done. I just have a power steering motor, and I've got that Cytron 30 amp driver board on that. I've just got an Arduino Nano as the controller. So right now I've got a pot stuck on my little proto board here. As I turn the pot, that says that's the requested position. And then I've got a 3-turn pot on the motor. So it just tracks it. So as I turn the pot back and forth, it just follows what it's the position I request. By turning the little pot, the motor goes to that position.
Okay. So you have 2 potentiometers. I understand that.
Yes.
Okay.
And the little one that I'm setting the requesting the position, I could just send in a number from Arduino and say, go to position 55 or 320 or whatever I want. It's just that it's more convenient. I can just turn that pot and watch it move. But now it's just a matter of, if I supply that number instead of from the A to D, I can just supply it from the command line. So I just type in a number and say, go to that position, and it should go there and stop.
Okay.
So this is
Okay.
just the first steps of making the motor move, and I've got it doing that now. So I just have to play with it a little
Okay.
more now and make it do something usable.
Chef, can you, maybe I didn't understand what you were saying in the beginning. You were using the Citron board to move the motor, and if and when you get the information when the motors find the um, the edge of the potentiometer by taking it from the power you are giving to the um, to the motor. I'm not sure if I'm being able to explain myself.
Well, I'll post the 2 lines of code that do that, and then I'll give you a demo here.
I think I use a fixed power level for mine and just adjust the
So I posted the 2 lines of code there. It just simply says if the potentiometer is beyond the maximum position that I've defined, and error is less than 0, error greater than 0. Oh, error is actually the direction at that point. So it basically says here, I'll give a demo. So here's my power switch.
Yes.
I just stick it on, and the motor's howling because I'm getting some noise from this pot. If I wiggle it, I got a loose connection there or something. But anyway, if you watch the motor and I turn it, and it's jumping because I got noise there. But anyway, it goes back and forth and follows it. But if I go too far, there it just shuts down. So I'm at one direction I picked like a count of 256, and the other end is like 768 or something. So it's like 25% of the travel at each end is now invalid. So if I move the pot back the way that code's written, if I move it back, it'll start running again. So now I'm running, I get the other end here, and then it shuts down at that end. So I can't go beyond that because it says, oh, we're at the end of the pot. We're at the specified limit that I put. I don't know if you can hear me since the microphone's pointed away from me, but
No,
Yes, we
it's
can
okay.
hear you.
It's okay.
so I can just arbitrarily set that range anywhere I want. So anyway, that may be something handy to consider. And those 2 lines, or those actually 4 lines of code that I posted may not make sense because since it says error instead of direction or something. It basically says if you're going towards the maximum and you exceed the boundary, and it says we still want to be going forward, then it just sets the value to 0. It just kills the power at that point. And then if I start backing off where the position is,
Yes, I understand. I understand another thing that you were getting some kind of measure from the Citron board when when you were giving extra pressure to the motor.
oh, that was something else. That's the on the board. It's got that potentiometer on the board here. And you just turn
Yes.
that. You can control
Yes.
how much power the board is putting out. So I'm not actually measuring
Okay.
anything from that. You can just go and you can set the power by doing that. Which brings up another
Okay.
point, because right now if I just push, let's see, is this going to work? Oh, I don't have the power hooked up. And something I didn't realize it would do this, and maybe it's the way I got the jumper set, but right now it's running and you can hear the motor whining. If I turn this, it turns. But if I come and just push a button now, oh, well, it's not doing what I thought. I was thinking that either one or the other would make it run. So right now it's doing the closed loop control. So every time I let go, it comes back. So it's not doing what I thought. If I were to disconnect the power right now, let me pull off the, which one's which here. PWM, the white one. If I pull off the white one, I think not. I have to be careful I don't smash my pot now because there's nothing limited. But just pushing the buttons will run back and forth. So what you could do is there's a place on here for the switches. There's some pads. You could run wires out and put 2 push buttons somewhere on your vehicle. And then the pot, you can set a jumper that uses the external pot. So there's some wires over here. So you could put a 1-turn pot somewhere on a panel. So if you wanted to, you could just say, disable your driver board, whether it's a Teensy or an Arduino, disable that. And just by, first of all, turn that power pot, turn it down to minimum, and then push one of the buttons and then turn that till it just starts moving. So now you could manually drive your tractor around without having to, I know Al's got a vice grip on top of his to turn it with, but you could have just 2 push buttons and a pot there. So if you say disable the microcontroller, you can just, by using those buttons, you can actually run the steering back and forth. So again, if you're, say, stuck out in the middle of the field, like Juan had one time, you could just put it in this mode and then run the steering back and forth, and then you need some way to control the transmission, I guess, beyond that. But so there's various ways you might be able to add little manual functions here to these override modes, like I was talking about last time. And at the moment, it's set up just like everybody else has, where I'm just ignoring the board itself. I've just got it cranked up to that pot cranked up to maximum power. So it's just my little Arduino board here is what's actually controlling the motor right now.
Well, I don't know if you have any interests or not. I mean, but I'm happy to give you the code that I have on my Teensy that's actually driving the steering motor. And it gets, this is the crux of it. That's, literally riding the driver that, drives that steering effort, that's setting those pins high or low, which is left or right, and giving it that steer effort. I get that whining noise on mine too.
Me too.
You're on mute, by the way.
It's because that's the default PWM routine. It's only like 500 hertz or 400 hertz or something. And probably I'm going to go looking around on the Arduino and see if they've just got a different command that's smart enough to give you a higher frequency PWM, in which case that would stop whining then if we do that. Otherwise, there's other ways to get around it, but it's annoying enough right now sitting on the table next to me. I'll probably look into it fairly quickly, how to fix that.
I don't know why, but in my tractor I got that noise. But let me show you in the video that we are using the Arduino. We are not having it. Wait a second. Here. No. No. I didn't. Chef?
Yes.
More?
No, I don't have anything else.
Wait a second. I'm trying to open my browser. I think that this will. simulator. Okay. And here, the last video. Yes. Wait a second. How can I share my computer? Okay. Are you seeing?
Yes.
You see that I don't get the sound?
Yeah, it's quiet as a church mouse.
Yes, I don't know why, because as I was telling you, this is our setup that we are working. I, I I was trying to show you the setup because I at some point I thought that you were will thinking that I was lying because I couldn't show you the photos because the guy that I am working with him, he's a millennial. He's a very young boy, and I asked him, give me the photos. Oh yes, tomorrow, and he always forget to send me the photos. But we had come out to the point that we get the complete setup of the tractor in the board, and now I think that maybe in a week or two we will be able to show the complete sequence of the boot up to check up the sensors, and let me show you the other video. Is this one? No, this one no.
So I would say if
And
your motor is quiet, you probably
Yes,
have a different command instead of that analog write command that is a standard Arduino thing. So you may have a different command that's generating that PWM signal.
yes. We have both. We have analog and digital command, but I don't remember which one. I think that he's using now the digital one, but I will solve it for the next meeting. I will try to bring up because one of the things that I have said to him is to put up the to push the files that we are using for testing, but he doesn't he does not know how to use GitHub. So I'm not having the files now. I think that next week I will be able to post them. Here our approach is I will try to put this OLED little screen. So if you can, are you seeing my computer?
I see
Yes.
hello world.
Okay, yes. So we are going to, as we go through the script, we are going to throw messages to that OLED screen saying, now we are using the motor. So if the motor is not moving, or if we are not getting feedback from one of the sensors, we will know that that sensor is having the problem to put it in the tractor. Well, here's the setup. Here we have the Citron board, the relay board. We are using an Arduino Uno for the testing. Here's the power management of the actuator, and here we have an accelerometer. We are going to use a GPS because I want to solve this to get a better heading. Besides my own GPS, I want another GPS in the tractor. And here we have a sensor, an infrared sensor, because I want to get the data of the speed of the motor, and maybe use it in the odometry too, because I want to test it in the future. Well, this is my setup by now. I hope that next week, look here, this is Ariel. Look, he's 17. I'm working with kids. So, well, I don't have nothing more now to share.
It looks like a really
yes.
neat layout.
Yes. I'm working on this. This maybe will be very stupid, but as I'm working in the simulator, I'm trying to build to trespass to this something similar of what we have in the lawn tractor, to get a smaller lawn tractor with the same setup of actuators, motors, and potentiometers.
With GPS
like
or
a
no
scale
GPS?
model. Yes. That's why I'm working with that U-block GPS there. But this is very initial. I'm just beginning to work with this. I wanted to have it like a side project for the same for the land tractor, but I need to work a lot in this.
Cool. Bob, anything to share?
Progress has been kind of slow, but I've been working on my control box, and an IT friend of mine volunteered to help me understand Windows 10 pretty good. And we set up and got Linux or Ubuntu onto a thumb drive. So now I can use my laptop and the thumb drive and start up in Linux right off the bat. Eventually we'll get to the double boot. I'll turn the video on and show you the control panel. This is steering left, right, forward, reverse, throttle, and 3-point hitch. These are go, no, and go switches. So down, I'm driving the tractor with switches, and it's connected to an umbilical cord down to all the motors. When it's in this position, nothing is connected, so it's dead. And then up, it switches over and starts using the motor controllers. Of course, with a microcomputer driving the motors. But I went this way because I want to be able to use the tractor at any time, but also to test each circuit individually, because I'm anticipating problems in coding. Eventually, this thing will sit in this box, which has a flip-up lid. And then I'll hang the boards underneath the panel with a piece of strap. And then the perf board will sit more or less on here, so I can lift the whole thing out of the box. I'll use a round connector, and so I can pull the umbilical cord right up out of the box, but everything will be connected to this, so the whole thing comes out and I can get to it anywhere. And as far as the perf board, I've got everything mounted, except right now I'm doing some other things. So there's just enough room between the bottom of the box like this, and then the wires from the switches, So I can slip this in and possibly get a top hat, or maybe put USB connectors if I need them, and raise this up. So that's about where I'm at right now. But what's encouraging now is that I'm pretty much understand how Windows 10 works and how to delve into it, and ready to start on using Linux and learning Rust. So that's about where I'm at. I'm years behind you guys.
Okay, we need to smooth the path out so you can slide in behind us.
I'll be going back and watching the videos from the past, try to get up to speed.
All in due time.
Yes. It's your time.
Anything else, Bob?
No, that's it.
All that mechanical stuff takes time. Trust me, I know. I think Jeff has done in a few weeks what it took me a year to do on that daggone steering motor.
But you are dangerous now.
Yeah, well,
Yeah, but
I go,
Yes.
and all I want to do is go. "Ooh."
But I think I've had
You
this
are
motor,
dangerous.
I think I've had this motor for 2 years though, so it's not as though I made drastic improvements overnight.
Anyway, Jeff, you posted motor position greater than max position. You posted some pseudocode there. Tell us what you did.
That was just the lines of code to limit it at the ends of the pot. So basically it says, every time through the loop, it just says, is the motor position greater than max pos, which I just arbitrarily set that to max is 768 and min is 256 out of 1023. So I wanted something so when it gets towards the end of the pot, it shuts down. Because if this thing goes into oscillation, I don't want it to bang up against my pot and break my pot. So I just have it so it shuts it down early. So basically it just says, if I send it the command, if the pot is already at or beyond the maximum position, and the next part that says and error is less than 0, it says if I'm telling it to go further, then it just simply kills the power to it. So the effect is, the things like this, it goes up like this, then gets to a certain point, the motor will just stop. So it just kills power completely. But if I set the position lower again, then it starts running again. It'll come over till I hit this side and it will stop. So that's just a way to, for debugging, I didn't want to break anything. And that's why I was saying then also on putting it on the lawn tractor that might have some other benefits you could use it for there also. But so that's just what that 4 lines of code are doing. It says if you get past the max, shut it down. If you get past the minimum, shut it down. But it's smart enough that if I give it a position back in the middle, so it keeps it from going beyond the max, but you can always back up. So it just automatically takes care of itself.
I would suggest the 3 of us do a line-by-line comparison of our steering control, low-level steering control code. When you get to that
Yes,
point,
I got the same. No, I got the same that you have, but the one that I show you is different. This week, this on Thursday, I gave the main CCP code that I was working to Ariel. That's the guy that is working with me. I asked him to look to the code because he knows CCP and he knows a lot of Arduino. He was looking I think that next week or the other week I will have some news about how he's handling it to don't get the noise. But I always get that noise. It's the first time that I don't get the noise.
because I mean, mine works. I don't think it has a true PID in it. I mean, it would just be, I think, they could use a little house cleaning.
Yes. The code you are talking about, the main CCP.
Well,
But we will get to that. We will get to that point because as I'm trying to achieve that security check code, we will get to the point that we can work that. The thing maybe that I find more difficult is to document the right way that code so that can be useful for everyone. So that was one thing that I was thinking. And the other thing that I have no knowledge about is the way that I was trying to work around this little tractor is to use a switch and actuator to simulate the way the transmission is working in our tractors. So I'm thinking in doing that kind of things to simulate that line of working, because it's very easy for this to work, because this work by electricity. So you invert the polarities and you go forward and backward, and that's not the way that I want it to work. I want to replicate the exact driving in this electrical that we have in the tractor.
well, I mean, I like the way that you guys have laid out the boards there and are trying to make it really clean. So yeah, I'm looking forward to seeing what you guys have are
Okay.
you're doing that step-by-step testing process. I think that'll really be useful.
Yes.
So
Okay.
Jeff, if you ever want to, I think my steering code is on the Google Drive someplace if you ever want to look at it, but you'll probably do a better job of steering code than mine.
And right now, mine, I just started at the simplest thing. I've just got straight proportional control. I don't have an I or D on any of it. I just say, compare the motor pot to my requested pot, subtract the two, and multiply it by, I think, a gain of 4 right now. And I'm fairly happy with the way it's working just sitting on the table here. I haven't tried, actually trying to move the steering with it, but. And if that doesn't work, if I try to get my response a little quicker, then I'll probably have to add a D parameter to my PID. Right now it's just P. There's no I and no D in it right now. And the other thing is I'll go track down this thing with the PWM command and try to get something that's quieter, because as I say, it's really annoying sitting here next to it.
And mine are reacting to ROS messages as well, right? So mine is subscribing to a ROS message and reacting to a ROS message. So at some point, you have to decide whether you want to use as input a ROS message or whether you're just going to take a sensor reading too. So anyway, things to think about.
Okay.
So anyway, well guys, happy hunting. I will be parameter tweaking and trying to go 5 meters. Just 5 meters straight. That's all I want. 5
Yes.
meters.
It's like a baby.
It's about this.
One step at a time.
Two of these.
That when my second child was born, he do the crawl but backwards.
Yeah.
Not forward. So I thought that he had a problem. So we take it to the doctor and say, look, the kid is not crawling forward, it's crawling backward. And he said, well, someone once crawled forward and the other crawled backward. It will be okay.
Just adjust that backup
So,
parameter.
well,
Where is that? Where's that backup parameter?
I don't know.
Okay, guys, have a
So-
great weekend.
Okay,
Ciao.
bye.
Okay, bye.
Bye, Bob.
Thanks, Al.